Hi, welcome to this management science tutorial entitled Minimal Spanning Tree. We've got a national grid consisting out of 10 cities. These are the brown circles. And they all could be connected via various paths. So for instance, to link node 1 and 2, we could choose this link with 400 miles. However, we want to minimize the total length which connects all cities. Okay, so how are we going to achieve that? Well, first we enter the data into Excel, we do some basic checks, and then we actually think about a solution method. That's probably the most important step. And then we develop a graph that shows the optimal network. And eventually, finally, we determine what is the total length that spans the whole network. Okay, let's start. Since we are going to need this quite often, I'm going to copy that graph into Excel. And here is Excel. We start Excel and paste our graph in there. Okay, so let's enter the data into Excel. What's the best approach? Well, we are going to numerate. So how many edges are there in total? That would be quite interesting. Okay, I'll abbreviate number with the hash, commonly done. And I'll just drag down a couple of edges. Not sure how many there are in this graph yet, but very important to figure out. Then my from node and my to node. Also, you see these edges are undirected. So in an algorithm, we probably have to duplicate then all the edges. Okay, anyway. This is a very efficient way to actually enter the data from to, and of course we would like to know the distance. Okay, we all should start with node 1. It's always good to start with 1 and see what are all the outgoing arcs. So they are all, the nodes to which these arcs go are all higher. We see 1 goes to 2 with a length of 400. 1 goes to 4 with a length of 520. And 1 goes to 8 with a length of 750. Okay, next node is 2. We continue. 2 goes to node 3 and node 4. We don't go back to node 1. The length 2-3 is 450 and 2-4 is 490. Now, next one is node 3. We go from node 3 to node 4, 5, and 6. 4, 5, and 6. And the distances are 4 is 580, 5 is 210, and 6 is 120. Okay. Next node is node 4, which goes to. So now I see the benefit of my input method. So I only look at the higher nodes. So also I've got 1, 2, 3, but I ignore them and just enter 5 and 8. The length for 5 is 310. 48 is 240 miles. Next node, 5. 5 goes to 6, 7, and 8. Corresponding lengths are 175, 260, and 340. Okay, I don't see my number anymore. I'll just resize that column. Node 6. We have to go all the way up to 10. Node 6 goes to 7 and 9. I can ignore 5 and 3. 7 and 9. 7 is 250, length 250, and 6 to 9 is 255. As I see, I will need some more numbers. Okay, now we enter more nodes. Node 7. Node 7 goes to 8, 9, and 10. 8, 9, and 10. 8 is 270 miles. 9 is 235 miles. And 7 to 10 is 320 miles. Next node, 8. 8 goes only to 10 with a length of 340. Now 9, node 9 goes only to 10, 260 miles. Good, this concludes the input of the data. So I'll call that task 1. And we are going to move from task 1 to the next one. Let's just copy that sheet, task 1 into task 2. Let's remind ourselves what is task 2. Do some basic checks. Number of edges, and that all nodes occur. Okay, so we've got 20 edges. So a good check would be now, are there 20 edges in there? So we could just go ahead with numbering all the edges, then we should see whether we've got all of them. That means we could just enter a little text box and say okay, that's number 1. Then continue and say this is edge number 2. Well, actually this was the other way around. Edge number 1, edge number 2, and edge number 3. So we can continue that way and should end up with 20. So this is one basic check. I'm just going to remove that now, but if you've got the time, you should really do that. Then the second check, do we have all nodes? Well, we have got all nodes in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we end up with node 10. As I said, this is a directed graph right now. In order to make to achieve a complete solution, we should actually have it undirected. Okay, so just saying, okay, the number of edges is fine, I've checked that, and the number of nodes is also good in here. Okay, task number 3. What is our task 3? We want to formulate the solution method, a procedure in words. And task 4, show a graph with the optimal network. Okay, let's do these 2 tasks in one go. I'm going to use Kruskal's algorithm, which is based on the idea of sorting the arcs and then letting trees grow together. It's a kind of clustering algorithm as well. Well, not just a kind of, it is a clustering algorithm. If you don't let it grow to a complete tree and just use the subtrees. Okay, so how do we do that? Well, first of all, I'm going to format this as a table. And my first step is going to be that I'll sort the arcs. So here I click on sort smallest to largest because I want to minimize the distances. And the idea is that I start with the smallest arc. So if I can span the tree with the first 9, so I only need 9 edges to actually span a tree, to create the tree, then that's definitely the minimal spanning tree. However, as we see, there can some issues arise. Okay, so according to this, we should start. Let's just change the font a little bit so that we don't get confused. Okay, so from node 3 to node 6, this is my first edge, which I should choose. So I'm going to insert that now in a line, which is of course a shape, and I'm going to draw that from 3 to 6. This is how we start. So we grow the tree which consists only out of node 3 and the tree which currently consists only out of node 6 together and get a joint tree, whilst all other nodes remain single trees. So this comment somehow demonstrate already why it's a clustering algorithm, or can be used as a clustering algorithm. Good. Next one. So we have now selected this one. I probably should make a quick note that I used and say yes, I've used that, and I have not used any of the others. So I'm going to set them all to 0. Here we go. Would be nice to see it actually as a nice beautiful icon. We can do some conditional formatting, and we can just go to the icon set and say okay, if I've used it, then I'll give it a green tick, otherwise an X. Okay, the next one, the next edge is 5 to 6, which basically just grows our current network, and I've used it now, so I'll set it to 1. The next one is 3, 5. Okay. 3, 5. Now this is of course an issue. As we see here, we are actually creating a cycle here, which we don't want. So that's not good. So we are going not to use this edge 3, 5. Okay, however, now we are in the position actually to formulate our algorithm a little bit more. I'm just going to crop that image a bit more. Okay, so what did we do so far? Our first step in this algorithm was to sort all arcs. Sort all edges actually, because we are just looking at an undirected graph. Sort all edges according to the distance. Then our second step was select the arc, the edge, which does not lead to a cycle, does not lead to a cycle. Well, let's see how we get on, whether there is still any issue or whether we can just continue until we have spun the whole tree. So we did not take 3, 5. So we look now at edge 7, 9, h7, 9 is 235. Here again we see we've got a cluster out of 3 nodes. Here we've got a cluster out of 2 nodes, and then we have got clusters with single nodes. So the closer they are together, they build, then they grow together. Okay, so we use this one. Next one, 4, 8. 4, 8, perfect. No cycle, we can add that to our tree. 6, 7. 6, 7 is good. No cycle. Next one is 6, 9, which would be a cycle again, so we cannot use that. So 5, 7 is the next one. 5, 7, another cycle, we cannot use that. 9, 10, finally something which we can add to our tree. So this was 9, 10. Next one, 7, 8. Perfect, we can use that as well. We continue with 4, 5, which would lead to a cycle again. So this is a very big cycle actually. We don't want that. 7, 10, another cycle. We don't want that. 5, 8, another cycle. We don't want that. 8, 10, another cycle. 1, 2. Perfect, we can use that. 2, 3. Yeah, perfect as well. Are we done already? Well, let's have a look. How many did we use so far? I'm just going to sum up all my used edges, and we come to the number 9, which is great, because since we have got 10 nodes, we know that we need 9 edges to actually span all nodes. So that means we have finished. So that means we can now write our final step in our procedure, which means finish when all nodes are spanned. That means number of edges equals number of nodes minus 1. Okay, so what we have just done is tasks 3 and 4. We have just created a minimal spanning tree. I'm going to copy that further to our final task, task 5. Our task 5 is to actually find the total length. So this is quite easy again. All we have to do is the length, the used length. Let's call it used length. Which is nothing else than multiplying the use factor with the distance. So here we see it turns to 0. We probably do not need any of this conditional formatting. If at all, then probably we should just have a data bar and nothing else. Alright, so task 5. Is the sum of these, which is 2400. That means we can conclude that we need 2400 miles in order to create a network, that a national grid actually, that spans these 10 cities. I hope you enjoyed this tutorial, and I'm looking forward to seeing you to the next one. Thank you.